Okay, what we're going to do on this problem then is we're going to find the area under the curves, between the curves, and we want to know what the area is in the first quadrant. So we're actually just looking right in here. We want to know this area right here. The thing is, we've got a couple different functions that we have to investigate. And if you'll notice, from 0 to 2, we're with one function. Okay, we'd be the red function minus the green function. But from 2 to 4, and if you'll see right here, 4 is where the magic happens. 2 to 4, I'm a different function because now that blue line comes in and takes over. So for this problem, we're going to look at the area, but we're going to look at two separate functions, okay, two separate integrals, and we're going to add those two integrals together. So we're going to start off with our top function, which will always be this guy. He's always going to be on the top, okay? So the first integral will look like from 0 to 2, square root of x, or x to the 1/2 power, minus the bottom function, which in this case is the equation y equals 0. Plus, and then we go from 2 to 4. And if you don't believe me on 2 to 4, then what you would do is you would set the square root of x equals x minus 2, and you would solve that out. And it'll tell you what value of x occurs where they are equal. And you'll see that square root of 4 is 2, and 4 minus 2 is 2. So that's going to work. So then we could do the top one again, which is going to be x to the 1/2 minus the bottom one, the whole bottom one, which is x minus 2. So there's that guy. If you're one of my students, you can use your calculator and punch this in. If you're in a class where you can't use a calculator and punch it in, then just use your integration rules. So we're going to look at this guy right here, integration of 0. He goes away. Remember, he's gone. Can't integrate 0. It's just 0. So what we end up with is x to the 3/2 divided by 3/2, which is 2/3 x to the 3/2. And we're going to evaluate that one from 0 to 2. Plus, and then over here we've got x to the 1/2 minus x plus 2. That's what we would be integrating. So this is going to be the same thing, x to the 1/2. So that's going to be 2/3 x to the 1/2 minus x squared over 2 plus 2x, and it is going to be evaluated from 2 to 4. And remember, on both of these, it's stop minus start. Stop minus start. So 2 cubed square rooted. All right? That's what we'd have here. And then on the other side, we still have that 2 cubed square rooted, so we would still have that same answer because there's the 2. And then we would use minus the 4. So I'm going to punch this into my calculator and get a final answer on this. You can work it out on your paper if you need to. And let's see if we match answers. So I did notice I left this x off when I integrated, so make sure you have that added in there. And I worked all this out on a sheet of paper because I've kind of run out of room here, and I wound up with 10 over 3 units squared. That's this area right in between these two curves. And what we're doing is we're taking the area of the first space, which we could call it right here, A1, plus the area of the second space right here, which we could call A2. Okay? We add those two guys together, you should get 10/3. So double check me. You can use your calculator. If your calculator gives you a decimal answer, you can plug in 10 divided by 3 and see if it gives you the exact same decimal answer. All right?